So next up we have Rachel from the University of Washington, who is going to be telling us some privacy threats concerns of commercial satellites.
Hey, hello everyone. Thank you for being here. My name is Rachel McCamus and I'm a PhD student at the University of Washington. And today I'll be presenting on Over Fences and Into Yards, Privacy Threats and Concerns of Commercial Satellites. This work is in collaboration with Matea Sim, Mia Bennett, and Yoshi Kono. So most of us are probably familiar with satellite images through applications like Google Earth. We can use these products to zoom in over our homes out of curiosity, but satellites have many more use cases than just that. They can help identify illegal activity, and the photo here shows a satellite image confirming illegal fishing. Satellite imagery also might be used for military and defense purposes, such as finding a North Korean submarine that was intended to be hidden under awning. Agriculture is another use case of satellite imagery, both to plan crops and monitor plant health with infrared. And the financial industry also uses satellite imagery to inform their investment strategies, like monitoring the number of cars in a grocery store parking lot to predict quarterly sales. In this work, we focus on commercial satellites. Commercial satellites are satellites not owned by the government that can sell data to many different customers, both inside and outside of the government. They can even sell data to you or me as individuals, which I'll get to later. While there are many forms of data that commercial satellites can collect, we focus on satellites that take images. So we've just seen some common use cases of satellite imagery, but what privacy implications might commercial satellite imagery have? What if satellite imagery was used to inspect people's activities in their backyards across time? What if it was used to track a car over time? What if it was used to track where a person is across time and that individual was tracked multiple times per day? While some of these use cases might not be fully possible today due to resolution constraints, they may be possible in the future. Before continuing, you should be familiar with some terms. Spatial resolution is the smallest dimension on the Earth's surface that can represent 1 pixel in an image. The upper right photo shows an image by the commercial satellite company Maxar at 15 centimeter spatial resolution. Temporal resolution is the frequency at which images are taken of a particular location. The highest temporal resolution available today is 15 times per day or even higher. And while we focus on just RGB images that are pretty much perpendicular to the ground in this work, this is not the only format that imagery is collected in. Off-nadir images are images taken away from perpendicular, like the one on the lower right. And synthetic aperture radar, or SAR, has night vision and can pierce through cloud cover. We believe that satellite imagery can and will impact privacy of the individual. Factors like spatial frequency, temporal frequency, and the amount of spectrums available are all increasing. In fact, even short satellite videos are becoming available. At the same time, the cost of satellite imagery is decreasing significantly, and the legislation and regulation on satellite imagery in countries like the United States are relaxing. For example, the US has recently relaxed the regulation on the most detailed spatial resolution that commercial satellite companies can sell. And to attest to the decreasing costs and the increasing ease of purchasing satellites, I was able to purchase a 75 centimeter resolution commercial satellite image over our university for just $175. Even a year before purchasing that, the minimum purchase price ranged from $5,000 to $15,000. And while we believe that satellite images can negatively impact individuals' privacy, they also pose benefits to society. To understand these trade-offs, we ask, what factors influence privacy versus utility considerations of satellite imagery? And with the considerations from research question 1 in mind, we aim to also answer question 2, which is, what possible approaches are there to protect individual privacy against commercial satellite imagery? On to the methodology. To answer our research questions, we split our procedure into 2 main steps. First is the pre-study. The pre-study consists of a brainstorming exercise with security and privacy experts and non-experts. We use this exercise to generate potential privacy concerns of commercial satellite imagery, and we use thematic analysis for this step. The second phase is our main study. We use the concerns found in the pre-study to construct an online survey of United States residents. We focused on the United States because we wanted to understand how U.S. residents' responses and concerns compared to current U.S. commercial satellite regulation. And we also focused on them because the U.S. has shown initiative in pioneering satellite regulation, such as committing to not perform direct descent anti-satellite missile testing. And we used Amazon MTurk to recruit respondents. We screened potential respondents for quality based on their past task performance, and for analysis, we used grounded theory and independent samples t-tests. We collected demographic data along axes of gender, age, race, and U.S. political affiliation. Our participant demographic skewed towards male, young, white, and Democrat. So, for our results, to summarize respondents' awareness of imaging practices, only around a third of them have heard of commercial satellites before this study. The guesses as to the cost of a single image ranged from $1 to $20 million. And the true temporal resolution capabilities of satellite imagery companies were higher than the average guess. This leads us to our first takeaway, which is that privacy expectations of satellite imagery do not necessarily align with commercial satellite privacy violations. We also asked respondents in free response form potential benefits and harms of commercial satellite imagery. For benefits, 21% of respondents mentioned mapping as a use case, and other benefits included real estate and infrastructure planning, targeted advertising, compliance and crime detection, emergency response, and studying natural phenomena. For harms, 52% of respondents used the words private or privacy in their responses without being primed with any mention of privacy or negative use cases of commercial satellite imagery. Other harms included facilitating crimes, unwanted advertising, surveillance and/or stalking, natural resource misuse, and incorrect identification of objects or people in an image. From these results, it's clear that participants are concerned about privacy issues with satellite imagery. Secondly, there is disagreement on whether applications are beneficial or harmful, as exemplified by advertising being mentioned as both a benefit and a harm. Based on these findings in our brainstorming session, we show respondents a set of entities that could have access to satellite images, as well as locations and activities that might be imaged. The column values are equal to the percent of the particular demographic group who find a use case acceptable. Overall, women were less comfortable than men with commercial satellite imagery for the use cases we posed. And Democrats were overall less comfortable than Republicans with imaging. These differences were statistically significant. So let's look at what people thought about whether the finance industry should be allowed to use satellite imagery. 37% overall said that they should, but only 29% of women said they should, versus 42% of men. And 32% of Democrats thought the finance industry should be allowed to use satellite imagery versus 53% of Republicans. Thus, imaging acceptability varies by use case, and there is no universal agreement on any one use case. Summarizing the resolutions participants were comfortable with, 41% are comfortable with 1 centimeter spatial resolution, which is higher than commercial satellite capabilities today. At the same time, 36% are not comfortable with images of themselves more than yearly, which is much lower than commercial satellite capabilities today. This shows that many are not comfortable combining high spatial and high temporal resolutions together, which means that the capabilities of commercial satellites today are not deemed acceptable by many respondents. After conditioning with positive and negative use cases that could violate individual privacy, we asked respondents about their general preferences towards satellite image access. Only 12% believed images should be available to everyone for free. 68% believe access to images should cost money and depend on the use case, which is common practice in the US today. Some believe paywalls on imagery will prevent abuse, while some believe that paywalls will promote abuse. And these results are interesting because the current trends in the geography field and geospatial data today are that image access should be free to everyone. So given these findings, what approaches can we take that consider the potential privacy and utility trade-offs of commercial satellite imagery? So multiple groups can work to handle these privacy utility trade-offs, including regulators and legislators. Many respondents suggested potential solutions to mitigate privacy harms of satellite imagery without being prompted. Therefore, we think it could be helpful for regulators and legislators to seek input from the public. We also suggest mosaicing images for some use cases, where small patches of images from slightly different times are patched together. That way there isn't as much time specificity, and it could make tracking people less precise. Another idea is to delay image release, again, to mitigate tracking and to prevent commercial satellite imagery being used for real-time combat, which is also a preference of the geography field. And lastly, there could be some logging mechanism to track who requested what image. We as researchers can also be involved. Researchers should explore sensing types beyond just perpendicular RGB images. We should also inspect off-nadir images and synthetic aperture radar, which I both mentioned earlier. And satellite data does not exist in a silo. We should understand the privacy implications of complementing satellite imagery with other types of data. And we should also understand how machine learning might exacerbate privacy concerns or potentially even help mitigate them. And comparative work is necessary so that we can understand the views of people outside of the US. And companies and designers should also be involved. They should weigh the privacy utility trade-offs of the solutions they provide. And there could also be mechanisms to request removal from all images. This is, of course, challenging since being removed from one country's set of images doesn't imply you'll be removed from all of them. And we discuss many more approaches and their challenges in the paper. Overall, there's insufficient awareness about commercial satellite imagery. People's privacy expectations and preferences often conflicted with current and future commercial satellite practices. And many stakeholders can work to mitigate potential harms of satellite imagery while maintaining their benefits. Thank you for listening.
Hi, thanks for the talk. I have one question on the survey results page with like the male-female Democrat Republican breakdown. I was curious about like how the different, how the different entities were chosen. Like, is this based on the share of which ones use satellite imagery the most?
So I think this was, you mean the axes of these particular demographics, why we chose to analyze by those?
Oh, no, sorry, like the entities, like agriculture. Like,
yes, so the entities that we chose were based on the first portion of the study, which was a brainstorming exercise between security and privacy experts and also non-experts. And we got a lot of people's opinions, and we also did our own brainstorming exercises, me and my advisor and other authors on this paper, to generate a set of potential issues. And also the paper shows a kind of, we created 2 code books, one for the activities that might be concerning, and then also one for certain privacy metrics that people were concerned about. For example, some activity maps to like being able to detect motion or what kind of activity someone's doing. So if you have, basically we just, I think, did I address your question?
No, that's fair.
Okay.
It's actually more of a curiosity. You worked on imagery, but you cited also other possible types of data that can be provided by commercial satellites. Since I'm not an expert, I was curious about what other types of data are available via commercial satellites. Thanks.
Yes. I'm certainly not an expert either. We did have a geographer on this paper, and we also had a psychologist who helped with the survey results. But there are different types of data such as, so the synthetic aperture radar is interesting. It's still imagery, but you can detect different textures. You can potentially detect metal military bunkers that are hidden underground, whereas you wouldn't be able to do that with RGB images. And I think that's one of the main ones that I'm concerned about now. And then part of the reason we chose to focus on imagery was because it would be simpler to ask people questions about that too, and have them conceptualize it.
So can I ask a question about, so there's been a lot of new entrants to space recently, so that potentially might not fall under sort of like the category of sort of like commercial satellite providers, where, I don't know, the cost of launching a satellite with a small CubeSat that'll be able to do some surveillance. How do you think people will be sort of viewing these kinds of systems? As well, they might be challenging to regulate as well.
Yes, I think they are challenging to regulate. How they view them, it pretty much depends on whether they're aware. I personally wasn't even aware of commercial satellite imagery pretty much a year before I started this project. So I think that's one of the things that we should address.
Cool, thank you very much.